About experimental research, chapter 6. What else? I'm behind. I need to catch up. Lots of things have been going on this summer. One of the problems that we had was the fact that they didn't turn on the class in time. It threw me way behind. I couldn't work on putting the class together. That was a problem. And then we had to hire people, one to replace me and the other one to replace Dr. Begay, Marilyn Begay, who we lost a year ago. Anyway, and so that took a whole week. The interview process took a whole week. But now we've done that, everything's in place. Slowly, I'll get back to getting everything done, but it's thrown me behind, and that's kind of unfortunate. But I'll catch up. I'll catch up. I know next week, this week is the fourth week, but I'll catch up. So let's go ahead and get started. We're talking about experimental research, or how experiments work. Um, you'll have to remember that not all experiments are the same, and so when they start talking about experiments, a lot of times it seems like, are they talking about medicine? And in reality, of course, we're just trying to understand how experiments work, so that you can create an experiment that is viable, that no one can argue with. That's what we're looking for. So there we go. Experimental. This is chapter 6, experimental research. I can't remember what's next week. I can't remember. An experiment is a type of study designed specifically to answer the question of whether there is a causal relationship between two variables. Do changes in an independent variable cause changes in a dependent variable? That's really what a experiment is about. Experiments have two fundamental features. The first is that the researchers manipulate or systematically vary the level of independent variable. The different levels of independent variable are called conditions. The second fundamental feature of an experiment is that the researchers control or minimize variability in variables other than the independent and dependent variables. The purpose of an experiment is to determine whether two variables are statistically related, and to do so in a way that supports the conclusion that the independent variable caused any observed differences in the dependent variable. The basic logic is this: if the researcher creates two or more highly similar conditions and then manipulates the independent variable to produce just one difference between them, then any later difference between the conditions must have been caused by the independent variable. That's the idea. So when I was doing my own research, we were looking at resilience. We were trying to figure out what leads to resilience among American Indians. And one of the things that we discovered was that it wasn't age, it wasn't... so what we discovered was that age didn't affect resilience, and education didn't affect resilience. What else didn't affect? Gender didn't affect resilience. Trauma did. Trauma didn't affect resilience either, which was different among American Indians as among other populations. And the one thing that affected resilience was level of culture, adherence to culture. An empirical study is said to have good internal validity if the way it was conducted supports the conclusion that the independent variable caused any observed differences in the dependent variable. Thus, experiments have good internal validity because the way they are conducted, with the manipulation of the independent variable and the control of extraneous variables, provides strong support for causal conclusions. The need to manipulate the independent variable and control extraneous variables means that experiments are often conducted under conditions that seem artificial or unlike real life. In many psychology experiments, the participants are all college undergraduates and come to a classroom or laboratory to fill out a series of paper and pencil questionnaires or to perform a carefully designed computerized task. An empirical study is high in external validity if the way it was conducted supports generalizing the results to people and situations beyond those actually studied. As a general rule, studies are higher in external validity when the participants and the situations studied are similar to those that the researchers want to generalize to. To manipulate an independent variable means to change its level systematically so that the different groups of participants are exposed to different levels of that variable, or the same group of participants is exposed to different levels at different times. The different levels of the independent variable are referred to as conditions, and researchers often give the conditions short descriptive names to make it easy to talk and write about them. An example would be this is medication that they're given. The guy can't sleep. They gave him one pill, it stayed awake. Two pills made him drowsy, but three pills knocked him out. Those are the conditions. One pill, two pills, and three pills. In this case, and it's simplified, of course. The manipulation of an independent variable must always involve the active intervention of the researcher. Comparing groups of people who differ on the independent variable before the study begins is not the same as manipulating their variable. For example, a researcher who compares the health of people who already keep a journal with the health of people who do not keep a journal has not manipulated this variable and therefore not conducted an experiment. This is important because groups that already differ in one way at the beginning of a study are likely to differ in other ways too. There are many situations in which the independent variable cannot be manipulated for practical or ethical reasons, and therefore an experiment is not possible. For example, whether or not people have a significant early illness experience cannot be manipulated. Early illness experience, making it impossible to do an experiment on the effect of early illness experiences on the development of hypochondriasis. Similarly, the number of concussions people have had cannot be manipulated, making it impossible to do an experiment on the effect of concussions on intellectual functioning. This does not mean it is impossible to study the relationships, only that it must be done using non-experimental approaches. In many experiments, the independent variable is a construct that can only be manipulated indirectly. For example, a researcher might try to manipulate participants' stress levels indirectly by telling some of them that they have 5 minutes to prepare a short speech that they will then have to give to an audience of other participants. In such situations, researchers often include a manipulation check in their procedure. A manipulation check is a separate measure of the construct the researcher is trying to manipulate. For example, researchers trying to manipulate participants' stress levels might give them a paper and pencil stress questionnaire or take their blood pressure, perhaps right after the manipulation or at the end of the procedure, to verify that they successfully manipulated this variable. An extraneous variable is anything that varies in the context of a study other than the independent and dependent variables. Extraneous variables pose a problem because many of them are likely to have some effect on the dependent variable. This can make it difficult to separate the effects of the independent variable from the effects of the extraneous variables, which is why it is important to control extraneous variables by holding them constant. And this was a problem in my research as well, because one of the extraneous variables was spirituality. The idea was, and this is something that was suggested to me by a colleague, he said, well, you can't study resilience without studying spirituality. But the problem was that I didn't really want to get into spirituality because there was on that reservation, almost everybody was Catholic. Okay, almost everybody was Catholic. Some people were traditional, and there was also the Native American Church was on the reservation. So there was Catholicism, there was traditionalism, where they adhered to their traditions. There was the Native American Church, which is more of a pan-Indian idea. And then there were evangelical Christian groups on the reservation as well. So we had four different forms of spirituality. So I didn't really want to get into the idea that traditionalism was caused resilience, or Native American Church caused resilience, or Catholicism caused resilience, or that the evangelicals caused resilience. That was a tough one because the evangelicals were adamant. They, if they had an Indian name, like some people had names that were obviously American Indian. The Talks difference, the Stiff Arms, the Donies. Trying to think of my buddy John Strike. Who else do I know? King was another one. Anyway, yeah, they had obvious Indian names. And so what the evangelicals did, if they had an Indian name, they didn't capitalize it. So if their last name was Doney or Talks Different or Stiff Arm or anything else that was obviously American Indian, then they didn't capitalize their last name. That was a little bizarre. Anyway, so I didn't really want to get into the whole spirituality thing. I was going to give them a spirituality quiz. I was afraid it would get into evangelicals versus traditionals versus Native American Church versus the Catholics. I didn't really want to get into the whole religious thing. So that was an extraneous variable that I did not deal with. Extraneous variables make it difficult to detect the effect of the independent variable in two ways. One is by adding variability or noise to the data. The second way that extraneous variables can make it difficult to detect the effect of the independent variable is by becoming confounding variables. A confounding variable is an extraneous variable that differs on average across levels of the independent variable. For example, in almost all experiments, participants' IQs will be an extraneous variable. And one of the reasons I didn't want to do the spirituality thing is because that would have added another survey to all of the surveys that they were already taking. They were taking 3 surveys, and they were filling out a questionnaire, a demographic questionnaire. And the spirituality would have added a 4th questionnaire. It was already a pretty thick I had to mail them out, so it cost me, I don't know, 75 cents or something. Now it's 73 cents, but back then it was in the 30s somewhere. So anyway, I didn't want to get into it, and I didn't want the argument as to whether traditionals were more resilient than evangelicals or Catholics or Native American Church. I just didn't want. And I figured, who cares what their spirituality is? They should care, but anyway, so I didn't deal with it. And the fact that the evangelicals wouldn't capitalize their last name was a little bizarre. In a between subjects experiment, each participant is tested in only one condition. It is important in a between subjects experiment for the researcher to assign participants to conditions so that the different groups are, on average, as similar as possible. This is a matter of controlling these extraneous participant variables across conditions so that they do not become confounding variables. The primary way that researchers accomplish this kind of control of extraneous variables across conditions is called random assignment, which means using a random process to decide which participants are tested in which conditions. Do not confuse random assignment with random sampling. Random sampling is a method for selecting a sample from a population, and it is rarely used in psychological research. Random assignment is a method for assigning participants in a sample to the different conditions, and it is an important element of all experimental research in psychology and other fields too. In its strictest sense, random assignment should meet two criteria. One is that each participant has an equal chance of being assigned to each condition. The second is that each participant is assigned to a condition independently of other participants. Thus, one way to assign participants to two conditions would be to flip a coin for each one. In practice, a full sequence of conditions, one for each participant, expected to be in the experiment, is usually created ahead of time, and each new participant is assigned to the next condition in the sequence as they are tested. One problem with coin flipping and other strict procedures for random assignment is that they are likely to result in unequal sample sizes in different conditions. Unequal sample sizes are generally not a serious problem, and you should never throw away data you have already collected to achieve equal sample sizes. However, for a fixed number of participants, it is statistically most efficient to divide them into equal sized groups. It is standard practice, therefore, to use a kind of modified random assignment that keeps the number of participants in each group as similar as possible. One approach is block randomization. In block randomization, all the conditions occur once in the sequence before any of them is repeated. Then they all occur again before any of them is repeated. Within each of these blocks, the conditions occur in a random order. The sequence of conditions is usually generated before any participants are tested, and each new participant is assigned to the next condition in the sequence. Between subjects experiments are often used to determine whether a treatment works. In psychological research, a treatment is any intervention meant to change people's behavior for the better. This includes psychotherapies and medical treatments for psychological disorders, but also interventions designed to improve learning, promote conservation, reduce prejudice, and so on. To determine whether a treatment works, participants are randomly assigned to either a treatment condition in which they receive the treatment or a control condition in which they do not receive the treatment. If participants in the treatment condition end up better off than participants in the control condition, then the researcher can conclude that the treatment works. In research on the effectiveness of psychotherapies and medical treatments, this type of experiment is often called a randomized clinical trial. It is common to hear randomized clinical trials referred to as the gold standard, the best existing approach for research on treatment effectiveness. There are different types of control conditions. In a no treatment control condition, participants receive no treatment whatsoever. One problem with this approach is the existence of placebo effects. A placebo is a simulated treatment that lacks any active ingredient or element that should make it effective, and a placebo effect is a positive effect of such a treatment. Many folk remedies that seem to work are probably nothing more than placebos. Although placebo effects are not well understood, they're probably driven primarily by people's expectations that they will improve. Having the expectation to improve can result in reduced stress, anxiety, and depression, which can alter perceptions and even improve immune system functioning. Placebo effects are interesting in their own right, but they also pose a serious problem for researchers who want to determine whether a treatment works. It could be instead that participants in the treatment group improved more because they expected to improve. While those in the no treatment control condition did not. Fortunately, there are several solutions to the placebo effect ruining a treatment experiment. One is to include a placebo control condition in which participants receive a placebo that looks much like the treatment but lacks the active ingredient or element thought to be responsible for the treatment's effectiveness. In research on psychotherapy effectiveness, the placebo might involve going to a psychotherapist and talking in an unstructured way about one's problems. The idea is that if participants in both the treatment and the placebo control groups expect to improve, then any improvement in the treatment group over and above that in the placebo control group must have been caused by the treatment and not by the participants' expectations. In a within subjects experiment, each participant is tested in all conditions. Thus, the comparison between the very same people under these different conditions. In other words, the person becomes their own control. The primary advantage of this approach is that it provides maximum control of extraneous participant variables. Participants in all conditions have the same mean IQ, same socioeconomic status, same number of siblings, and so on, because they are the very same people. Within subjects experiments also make it possible to use statistical procedures that remove the effect of these extraneous participant variables on the dependent variable and therefore make the data less noisy and the effect of the independent variable easier to detect. The primary disadvantage of within subjects designs is that they can result in carryover effect. A carryover effect is when being tested in one condition affects the participant's behavior in later conditions. One type of carryover effect is a practice effect, where participants perform a task better in later conditions because they have had a chance to practice it. They've done it before. Another type is a fatigue effect, where participants perform a task worse in later conditions because they become tired or bored, because they've done it all before. Being tested in one condition can also change how participants perceive stimuli or interpret their task in later conditions. This is called a context effect, an unintended effect of the context in which the response is made. Carryover effects can be interesting in their own right, but when they are not the focus of the research, carryover effects can be problematic. Any difference between the conditions in terms of the dependent variable could be caused by the order of the conditions and not the independent variable itself. The solution to the problem of order effects is counterbalancing, which means testing different participants in different orders. Counterbalancing. Random assignment plays an important role in within subjects designs, just as in between subjects designs. Here, instead of random assigning to conditions, they are randomly assigned to different orders of conditions. In fact, it can safely be said that if a study does not involve random assignment in one form or another, it is not an experiment. Almost every experiment can be conducted using either a between subjects design or a within subjects design. Researchers must choose between the two approaches based on their relative merits for the particular situation. Between subjects experiments have the advantage of being conceptually simpler and requiring less testing time per participant. They also avoid carryover effects without the need for counterbalancing. Within subjects experiments have the advantage of controlling extraneous participant variables, which generally reduces noise in the data and makes it easier to detect a relationship between the independent and dependent variables. Of course, you should be thinking about how you will obtain your participants from the beginning of any research project. Unless you have access to people with schizophrenia or people in prison, for example, then there is no point of designing a study that focuses on these populations. But even if you plan to use a convenience sample, you will have to recruit participants for your study. There are several approaches to recruiting participants. One is to use participants from a formal subject pool, an established group of people who have agreed to be contacted about participating in research studies. For example, at many colleges and universities, there is a subject pool consisting of students enrolled in introductory psychology courses who must participate in a certain number of studies to meet a course requirement. Researchers post descriptions of their studies, and students sign up to participate, usually via an online system. Participants can also be recruited by posting or publishing advertisements or making personal appeals to groups that represent the population of interest. In many field experiments, a task is not recruiting participants but selecting them. The point of having a well-defined selection rule is to avoid bias in the selection of participants. A field experiment was conducted on the effect of being smiled at on helping. A Confederate walking down a stairway gazed directly at a shopper walking up the stairway and either smiled or did not smile. Only if the person gazed back did they become a participant in the study. Shortly afterward, the shopper encountered another Confederate who dropped some office supplies on the ground. The dependent variable was whether or not the shopper stopped to help pick up the office supplies. And this is a little bit more than that. This is Boulder High School. At the end of the year, they throw paper. I'm not exactly sure why. It is surprisingly easy to introduce extraneous variables during an experimental procedure. For example, the same experimenter might give clear instructions to one participant, but vague instructions to another. For one experimenter might greet participants warmly, while another barely makes eye contact with them. To the extent that such variables affect participants' behavior, they add noise to the data and make the effect of the independent variable more difficult to detect. If they vary across conditions, they become confounding variables and provide alternative explanations for the result. This is, of course, Kanye West in an interview, and for some reason he was laughing, and then all of a sudden went cold. He's been diagnosed, he says he's been diagnosed with bipolar disorder. This would be rapid cycling if he went from happy to sad that rapidly. Researcher Robert Rosenthal has spent much of his career showing that this kind of unintended variation in the procedure does in fact affect participants' behavior. One important source of such variation is the experimenter's expectations about how participants should behave in the experiment. This is referred to as an experimenter expectancy effect. For example, if an experimenter expects participants in a treatment group to perform better on a task than participants in a control group, then they might unintentionally give the treatment group participants clearer instructions or more encouragement, or allow them more time to complete the task. The way to minimize unintended variation in the procedure is to standardize it as much as possible so that it is carried out in the same way for all participants regardless of the condition they are in. Here are several ways to do this. Create a written protocol that specifies everything that the experimenters are to do and say from the time they greet participants to the time they dismiss them. Create standard instructions that participants read themselves or that are read to them word for word by the experimenter. Automate the rest of the procedure as much as possible by using software packages for this purpose or even simple computer slideshows. Anticipate participants' questions and either raise and answer them in the instructions or develop standard answers for them. Train multiple experimenters on the protocol together and have them practice on each other. Be sure that each experimenter tests participants in all conditions. A good practice is to arrange for the experimenters to be blind to the research question or to the condition that each participant is tested in. The idea is to minimize experimenter expectancy effect by minimizing the experimenter's expectations. You can develop a double-blind study, an experimental research design, in which both the participants and the experimenters are unaware of which condition the participant has been assigned to. A single-blind study is one in which the participant, but not the experimenter, is blind to the condition. Single-blind, double-blind. It is always a good idea to conduct a pilot test of your experiment. I've always called this a pilot study, but for some reason your textbook calls it a pilot test. A pilot test is a small-scale study conducted to make sure that a new procedure works as planned. In a pilot test, you can recruit participants formally, for example, from an established participant pool, or you can recruit them informally from among family, friends, classmates, and so on. The number of participants can be small, but it should be enough to give you confidence that your procedure works as planned. One of the things that you have to remember is the individuals in the pilot study, you cannot use them in your study. You can't come back and put them in your sample. There are several important questions that you can answer by conducting a pilot test. Do participants understand the instructions? What kind of misunderstandings do participants have? What kind of mistakes do they make? And what kind of questions do they ask? Do participants become bored or frustrated? Is an indirect manipulation effective? You will need to include a manipulation check. Can participants guess the research question or hypothesis? How long does the procedure take? Are computer programs or other automated procedures working properly? Are data being recorded correctly? And that is the end of the lecture. So I will talk to you again next week. This is week 4, chapter 6. Next week is week 5, chapter 7.